Yeah, so today I'll be talking about the application of structure promotion multi-view stereo in underground mining to record development phases in digital format. So this presentation is based off a publication I recently submitted as part of my PhD project looking at the structural paragenesis of the Dougal River deposit. So structure promotion is widely used in the mining industry from exploration to put face mapping and determining the volume of your waste dumps, but little is discussed about its application in underground mining. There we go. Yeah. So firstly, why digital photogrammetry in underground mining? So one of the main benefits is the fact that you are able to record your entire development in digital format, or sorry, continuous digital format or virtual outcrop, as shown in the figures here. So these are two levels spaced 25 meters apart, and they span about 60 meters. So you can either load it as one continuous outcrop or individually per cut or capture. So from a safety perspective, though, is that it allows for mapping of inaccessible areas such as unsupported ground and faces. It's very easy to use using off-the-shelf equipment such as digital cameras and portable lights. Because it's a virtual outcrop, it means that you can do remote interpretation and mapping of underground development. And this technology has been used at Dougal River since early 2017. And the last I checked, I think they had about 5,000 headings captured. And it's allowed me to basically look at faces that were blasted several years ago and pull information from it. So in one slide, what is structure promotion multi-view stereo? So it's a method that generates a 3D scene from a series of overlapping 2D images that are captured from multiple angles at from different positions. So usually it's described in a two-step process. The first step involves the detection of distinct features in images and alignment. This is an iterative process that starts with two images and can be computationally intensive the more images you have. Then bundle block adjustment uses the features to estimate internal and external camera parameters to determine the camera positions and the 3D geometry of the scene. And this results in a sparse point cloud, which is shown in the top right. Then the second step uses the estimated camera parameters and position to generate a dense point cloud or a 3D mesh, which is shown in the bottom right. And this uses multi-view stereo algorithms. So structure promotion uses the principle of garbage in, garbage out. So to avoid that, what you want to do is capture very high quality images, and therefore you get high quality capture. This is in part governed by the camera settings. And so what I mean by that is the exposure of your images need to be correct. And these are governed by three camera settings, so ISO, aperture, and shutter speed. So to keep things short, the main two that you want to look at, the main thing you want to look at is ISO and aperture. So ISO is your sensitivity of light for the sensor, and aperture is the diameter of the diaphragm. So these can be set by the user using the camera's AV mode or aperture priority, and this allows ISO and aperture values to be adjusted with the camera automatically adjusting the shutter speed. So I ran a few tests at Dougal River playing around with combinations of ISO and aperture and found that the best was a low ISO value of 400 using an f-stop of 8. So f-stop 8 also creates quite a depth of field in your image, so your foreground to your background is very sharp as well. Then what I mean by a correctly exposed image is shown in the diagram in the bottom left. So an underexposed photo would be the one on the far left, where you look at the distribution of the histogram. It's shifted more towards the black tones. And when you look at the photo itself, you can see there's quite dark areas in the photo. This is actually due to the fact that the lighting isn't sufficient enough, which I go into a little bit later. Then example of overexposed photo shown on the far right. Here, the distribution of the histogram is more towards the white tones, and is shown in the photo by the bright areas. So this is due to mainly the fact that the lights weren't positioned correctly and a high ISO value. Then a correctly exposed image is shown in the center. So once the camera settings are set, sorry, is that better? All right, okay. So yeah, one of the most important things is very good lighting, and it cannot be stressed enough. So what you want to have is diffuse lighting, which covers the entire scene to be captured and minimize the amount of shadows as much as possible. And then furthermore, the light shouldn't be moved during the capture. So what I used here was 6 lights, so 3 on the floor and 3 raised above the ground, about shoulder height for me. This allows for lower ISO values and shorter exposure times. Then the next thing to look at is using ground control points, which allows the capture to be georeferenced. You need at least 3 ground control points, but we use 4, so 2 on either side of the capture. Show it. So that's the ground control points there. There's 2 of them on either side. These are just surveyed using a total station. Then for structure for motion to work correctly, you need to capture the scene from multiple angles and different positions. But because of a tunnel, you're limited in where you can place your cameras. Thus, you typically use 4 of them and then take several photos from the same station. So with my camera, I had to take 6 images to capture at least half of the scene. And this was a total of 24 images. And this results in about 9 images, overlap of 9 images on the face. Oh, sorry, not too far. Yeah, then lastly, before you actually take the photo, you should wash down the face, as this enhances the features. So when it comes to processing the captures, there are numerous software packages. So Corey said Atom Tech, but I used Metashape because it's, in my opinion, a bit better. So they all take the same approach, which is a workflow-based methodology. So what that means is if you look on the right image over there, typically what you would do is you would start from the top and move down the list. And all you have to do is at each step just apply some parameters such as what quality you want. And one of the main things is manually tagging ground control points on the images. So this is normally fine when you're dealing with a capture once in a while, but when you're dealing with an active mining environment, you can reach a point where it becomes inefficient. So for instance, at Dugald River, they average about 7 captures per day, with each capture taking about 20 minutes to process. And notably, most of this time is actually spent just watching the computer do the processing. So what I did instead is I looked at the Python API that's released with Metashape Professional and developed a script that automatically processes the captures. So, sorry, I won't get into too much detail on how it works because it's quite complicated, but that's discussed in the paper that I submit. So because it's the simple GUI, you pretty much just browse for the project setup spreadsheet and then let it run, and then a couple hours later you come back and you have your capture processed already. So all this needs is minor modification of how you'd normally do the capture. The first one being how you get your ground control points. So most software packages will include coded targets. This is usually due to, well, this is mainly to make life easier for large area captures when you're using a drone or something like that, where you may have dozens of ground control points that need to be manually tagged onto thousands of images. So using this system, I removed the fact that you would have to manually tag the images. Then the other one is, like I said, you have a spreadsheet that you load into the GUI, and it then pulls out the various parameters that you require to further process the capture. So some of the parameters are things like the project name, the location of the images and the servo file, and so forth. But the main thing is the next major step, which is to trim unnecessary data from the capture. So what I mean by that is it removes the unnecessary parts of the capture. So the ground support mesh, this part over here, and the floor, these tend to also create artifacts within the rock mass, which makes no sense. So yeah, that would be an example of a untrimmed capture, and then the one at the bottom there is an example of the same capture, but it's been trimmed. So all this requires is additional 4 points to be surveyed. They don't need to be well, they're not used for georeferencing, but rather their position is important because there's some geometry that needs to be calculated within the script. So what can you do with digital photogrammetry? So the main application would definitely be the fact that it's a virtual outcrop that's being georeferenced within your mine grid, meaning that you can directly digitize polylines and orientated disks onto the virtual outcrop. And as well, you can use background data or backdrop data such as drilling, lithological, and fault surfaces. But unfortunately, this is susceptible to backlog. Thus, the next logical step would be to automate the mapping as well. So I've been working on a script that automates mapping as well, and the idea would be to integrate this with the structure for motion automated script. So for instance, here what I have is a script. I told the script to look for the S2 foliation within a couple of captures and return some orientated disks. Then what you can do with this is you feed it into the same data set that you use to do fabric modeling. So example of that would be on the right over here. So this is a series of form surfaces that represents the undulating S2 at Dugald River. Then beyond the structural mapping, you can start looking at lithological mapping. So with this part of the script, what you do is you delineate your lithological zones within a capture, as well as your ore waste domains. So in conclusion, structure from motion, sorry, oops. So yeah, in conclusion, structure from motion gives you a digital record of your underground development in which you no longer need to do physical face mapping. And the captures can be viewed post-blasting. The fact that it's a virtual outcrop allows for remote mapping and interpretation, which during the banned interstate travel allowed a lot of the Dugald River geologists to work from home. And again, with my project, it allowed for a knowledge-based study to be done on captures or faces that were no longer available to map. It's ridiculously easy to set up using inexpensive equipment. So you could pretty much go to Bunnings in the morning, grab some lights, go to a camera hardware camera store, buy a camera, and by the afternoon you're already, capturing your data in digital format. It's also a very short training periods. And then, like I showed there, you can automate the processing using my script. Then it can be used in downstream processes that can also be automated, such as lithological and structural mapping. Notably, this is objective-based mapping, meaning that it's reproducible. And then I think at the end of the day, it will eventually be able to be fed into 3D models to update your models in real time. All right. Thank you.
Thanks, Peter. Any questions? Peter? Derek's coming.
Just a simple one. How do you classify the ore and waste? Is it from the drill data or is it just observation?
Observation. So the principle behind it is when you're standing at a face and you want to do the grade control, you would look for colors, right? So all the script does is basically do the same thing, but a lot faster and more accurate. Does that answer your question?
Yeah, so you're just looking. So you're just using the script to sample the colour pixels and then make a guess at what grade or it should be, i.e. shale versus sulphide.
Yeah, I don't think you'd be able to say exactly what the grade is, but more likely the percentage of sulphide in the face versus, waste rock.
And did you write the script in Python or something similar?
Python.
Yep.
So once the paper is reviewed and accepted and such, you'll be able to download the script and it's executable. So you actually don't need to use Python or anything like that. But the script will be available with it if you want to make modifications to it.
Oh, that's great. All right. Are there any questions online? Nope. Thanks, Peter.